Hey, AP Physics 1 students. So this first video is on 1D kinematics. That's actually the first unit that we're dealing with, 1D kinematics. And kinematics deals with both describing the motion of objects and predicting what the future motion of objects will be like. 1D kinematics means one-dimensional, so we're dealing with things that are moving along a line, either just left and right, or just up and down, or just along a diagonal. But in the future, we'll deal with objects that move in 2 and then 3 dimensions. So let me give you an example of kind of a word problem describing the motion of an object, and we'll talk about some vocabulary and some terminology associated with analyzing the situation. So suppose I tell you that a person walks 8 meters east, 12 meters west, let's see, 6 meters east, and then 5 meters west. Okay. And then we can ask a couple of questions. So the first question, I'll say this is A, is uh, how far did the person walk? And then part B, we can ask uh, how fast was the person moving? All right, so we have a description of an object moving just east and west. That means the object is moving along a line. It's moving in one dimension. And one-dimensional kinematics is exactly what we need to describe what's going on here. Now, I'm going to start by drawing a little picture of what's happening. What I've just drawn is simply the line along which the person is walking, and I'm going to label it X. This is my X axis along which the person walks. And the units that I'm going to be labeling on the X axis, the units of position are going to be measured in meters. So let's see, where does the person start? Maybe the person starts at X equals 0. We're not really told. So I'll define X equals 0 as to be where the person started. This is the origin of this coordinate system that I'm setting up. And first they walk 8 meters to the east. Now I have to indicate where's east and where's west. I could choose east to be to the left and west to the right, but I'll decide to label my coordinate system with east on the right side and west on the left side of the origin. And so they walk 8 meters east. I'm going to label this as clearly as I can. So 8 meters east, they're going to end up at X equals 8 meters. Then they walk 12 meters to the west. So from that position, they walk 12 meters to the west. That takes us to X equals -4 meters. Then they walk 6 meters east. 6 meters east takes us from X equals -4 to X equals 2. And finally, they walk 5 meters west. So 5 meters west is going to take them here, and they're going to end up at -3 meters. So just to recap, they walk 8 meters west and end up at X equals 8. They walk 12 meters, east and end up at X equals 8. They walk 12 meters west and end up at X equals -4. Then they walk 6 meters east again and end up at X equals 2. And finally, they walk 5 meters west and end up at X equals -3. So I'm just going to put a little dot here and label this I for the initial location of the person. They start at the origin. And I'm going to put a dot here and label it F. That is the final location of the person. All right, now in order to talk about how far the person moved, there's two different ways in which we can answer this question. one thing we can do is, right, how far did they move? Well, I could just add up uh, each uh, segment length that I drew in the picture above. In fact, let's do that. First, they walked 8 meters, then they walked 12 meters, then they walked 6 meters, then they walked 5 meters, and all of this adds up to 31 meters. Now, this is what we call the distance that they walked. I'll use lowercase d for distance. To find the distance that they walked, you just add up how many meters they walked to the right, to the left, to the right, to the left, like this, and you get this final value. So what is distance exactly? Let's define it. Distance is the path length that the person traverses. So path length is just the total length of ground that they covered. And notice, even when they backtrack to the west and then go back to the east and backtrack to the west, they keep racking up additional meters of path length that they're traversing along the ground. If, for instance, you go out for a 5-mile run or something like that for exercise, this is what you care about. You care about uh, traversing a path length of 5 miles, running a distance of 5 miles. And it's totally fine if you run back and forth and retrace your steps. You're going to get your 5 miles in so long as the distance you run is 5 miles. On the other hand, there's another sensible way to answer the question, how far did the person walk? So the person started here, right? That was the initial location at x equals 0. And they ended here. That was the final location at x equals -3. So how far did they walk? I can draw an arrow pointing from the initial location to the final location. And notice that arrow is 3 meters long, and it points to the west. So I could also say that how far did they go? They went 3 meters, comma, west. This is another reasonable way to talk about how far they move. Now, in this case, we're not talking about the total path length traversed. We're talking about where they ended up relative to where they started. They ended up 3 meters west of where they started. And this is what we call displacement. I'm not going to introduce a like symbol for displacement, like I used little d for distance. I'm just going to say that's the displacement. How about a definition here? So displacement is how far and in what direction an object moved. Here's the key, relative to when it started. So relative to where this object started, although it traversed a distance of 31 meters, it only ended up 3 meters to the west from where it started. And that is what we would call the displacement of the object. Distance is just a positive number of meters, but displacement is a positive number of meters, comma, direction. Unlike distance, which has no direction associated with it, displacement does have a direction associated with it, and you should not forget the direction. Now, in this case, the problem referred to directions, east and west. A different problem might refer to directions like up and down, or left and right, or north and south. You should always use whatever language the problem introduces when you're discussing the displacement of an object. And if there is no direction supplied, no like words like east, west, north, south, then you can just talk about the positive x direction and the negative x direction. So it would be reasonable to say, let's say 3 meters, comma, negative x direction. That would be an okay way to talk about the displacement of this person in this problem if we were not supplied with the terminology east and west in the question itself. All right, so two different ways to talk about how far the person walked. Oh, I should point out one thing here. Um, if I didn't draw this picture, let's say I didn't have time or something to draw this picture, although I recommend you do draw these little diagrams, the way to find the displacement would be the following. What you're trying to find is the change in the position, the change in the x coordinate where the object is located, which is called the object's position. So we're trying to find delta x, the change in position. And in this case, because the eastward direction is positive and the westward direction is negative, I could compute the change in the x coordinate of the person by noting that the person walks 8 meters east, so that's positive 8 meters, 12 meters west, but west is the negative direction, so I subtract 12 meters from the position, 6 meters east, so I add 6 meters, and then 5 meters west. West is the negative direction, so I subtract 5 meters. So notice each eastward part of the trip is a positive number, each westward part of the trip is a negative number. And when you add all these numbers up, yeah, you get negative 3 meters. Just take a moment to confirm that. Okay, so the change in x, the change in the x coordinate is negative 3 meters. Because west is the negative direction, I would say that the displacement is 3 meters west. That negative sign is actually telling me the direction is to the west, and I always have to format it like this, a positive number, comma, direction. Okay, so much for distance and displacement. How about part B? We are asked how fast the person was moving. Now, just realized, and maybe you realized too, that if I don't give you some sense of how much time this process took, you have no way of figuring out how fast the person is moving. So let me add that in here. Suppose I say the journey lasts 10 seconds. That seems like a long, well, yeah, maybe they're really fast, really fast. So 10 seconds. Okay, so now I'm stipulating that this entire process lasts 10 seconds. So how fast did they move? Well, we don't really know kind of the moment to moment details of this process. For instance, they could have run slowly to the east, then really quickly to the west, then really quickly to the east, then really slowly to the west. How fast they were moving may have changed from moment to moment, and we don't know about those fine level details. But we do know overall they traversed a distance of 31 meters, and that took 10 seconds. And that lets us find something called the average speed of the object. So SAVG as a subscript is average speed. And to find the average speed, you just divide the distance traversed by the time interval, the change in time, how much time it took for that distance to be traversed. In this case, 31 meters of distance were traversed in seconds, which gives us 3.1 meters per second as the average speed. Okay. So what is this saying? Well, the average speed of an object is the average rate at which path length was traversed. It's computed by looking at the distance traveled. So the object traveled a distance of 31 meters, zigzagging back and forth. The object traveled that distance of 31 meters in 10 seconds of time. So on average, the object had to traverse 3.1 meters of distance per second. And therefore, the average speed of the object is 3.1 meters per second. Maybe at a certain moment, the object's speed was much bigger than that. Or maybe at a different moment, the object's speed was much less than that. But on average, it must be true that the object traversed 3.1 meters of path length per second. Okay, what about well, is there another way to address how fast the person was moving? There is. We can also talk about the average velocity of an object, v average, which is the object's average velocity. The object's average velocity you can find by, you might have guessed this, dividing the displacement, or in this case, dividing the change in the x-coordinate by the change in time. So the change in the x-coordinate, remember, was -3 meters. And the change in time is 10 seconds from the start to the end of the journey. So we get -0.3. Look at the units, meters per second. So -0.3 meters per second. The way I would write this out is the following. I'd say the average velocity is 0.3 meters per second, comma, west. So notice, just like displacement is a positive number and a direction, velocity is a positive number and a direction. Now, what does that actually represent? All right, let me write this out in the space that I have here. The average velocity of an object is the average rate at which the object made progress away from its starting location plus the direction. Let me bring that up on screen so you can see it. Okay. There we go. So the average velocity of an object is the average rate at which the object made progress away from its starting location plus the direction. And therefore, average velocity is intimately related to displacement. The average velocity of this object is 0.3 meters per second to the west. Now, sometimes this object was traveling, at certain times this object was traveling to the west, at other times it was traveling to the east. But because it ended up 3 meters to the west of where it started, that's its displacement, 3 meters west, then I know on average it must have been traveling in the westward direction. Yes, it was traveling east sometimes, west sometimes, fast sometimes, slow sometimes perhaps, but on average it must have been moving at 0.3 meters per second to the west, so that after exactly 10 seconds, it moved a full 3 meters to the west, which is what the object actually did, according to this story here. Okay, so just to recap with some physical examples, I'll be repeating myself a little bit, but if you go out for a run and someone says, how far did you run? It doesn't matter where you started and where you ended up, how much you backtracked, how much you ran in a circle or whatever. All that matters is the distance you traveled, the path length you traversed. On the other hand, if let's say there's a fire in your house and you run away, your goal is to get far away from where you started. You would want a big displacement, which is how far you ended up from where you started and the direction in which you moved. If you're running a race, what you care about is having a large average speed relative to your competitors. You want to traverse more meters of path length per second on average than your competitors. Sometimes your competitors might be faster than you, sometimes your competitors might be slower than you, but on average, you better move across more meters of path of ground per second than your competitors to win the race. And finally, average velocity, that's kind of telling you how efficient you were at getting away from your starting point. How rapidly did you get away from where you started? If you backtrack, your average velocity comes down towards zero, because if you move back towards your starting point, the rate at which you're getting away from where you started is not very big. But that's what the average velocity is capturing. How rapidly, on average, were you making progress getting away from where you began and the direction in which you we were in class right now, this would be stretched out over a, 40-minute or even longer period of time. I'd be taking questions and things like that. We don't have the luxury of that sort of format, given the given the video format that we're forced to work with over here. But I think that's a good introductory video to the concepts of distance, displacement, average speed, and average velocity. You know what I'll also tie in here? I'll tie in one more thing, which is uh, instantaneous speed and instantaneous velocity. Uh, Remember, the average speed and average velocity is not telling you what happens at any particular moment. There's a different different terminology if you want to know what's happening at a particular moment in time, not average over a time interval, but at a particular moment in time. Instantaneous speed and instantaneous velocity are these at a moment equivalents to the average speed and average velocity. These represent what is happening at a particular moment in time. So if I had a video, let's say, of the person here running east and west, I could say right now, what's the person's speed right now? What's the person's velocity right now? And by that, I would mean instantaneous speed and instantaneous velocity. And if you analyze a small section of this video recording, you can zero in on kind of how fast they're moving and in what direction they're moving at a particular moment in time. So we can just call these quantities speed and velocity. Meaning, if someone says, what's the speed of the object at this moment? What's the velocity of the object at this moment? You don't have to add the word instantaneous, but you could if you wanted to be more unambiguous in what you're asking for. Speed and velocity. Speed and velocity, also known as instantaneous speed and velocity, are both evaluated. They're figured out at a time t, at a particular moment, a particular time. Average speed and average velocity are evaluated for a time interval, So there's a difference between a time t, which is a particular moment, maybe like 3:04 p.m. That's a time t, versus a time interval, delta t. I mean, for instance, like the movie lasted 90 minutes. 90 minutes is the time interval value for that movie. And that hopefully clarifies for you a little bit what we mean by speed and velocity in the instantaneous sense, or average speed and average velocity in the sense of evaluating what's happening for an entire time interval. Okay, there'll be some associated practice problems and post the solutions for those as well, and you can work through them, and more to come. Thanks a lot.